A single probability describes one event. But usually we want the whole picture, every possible value, and how likely each one is. That complete picture is a probability distribution. And one distribution, the bell curve, appears so often in nature and machine learning that it deserves special attention. First, a random variable, just a quantity whose value is uncertain. The number rolled on a die, the height of a random person, tomorrow's temperature. A distribution assigns a probability to each value it might take. For a die, the distribution is flat, every face 1 in 6, all outcomes equally likely. We picture a distribution as a histogram. Bars 1 per outcome, with height showing how likely that value is. Roll a die thousands of times and the bars level out flat and equal. But add 2 dice and the shape changes, 7 becomes far more common than 2 or 12. A peak emerges in the middle. Push that idea further and you meet the star of the show, the normal distribution, the bell curve. A smooth hump, symmetric, tall in the middle, thin at the tails. Most values cluster near the average, and extremes grow rare fast. Heights, measurement errors, test scores, countless things in nature take this exact shape. The bell curve has just 2 knobs. The mean sets where its center sits, the average value. The standard deviation sets its width, how spread out the values are. A small standard deviation gives a tall, narrow spike, a large one a wide, flat mound. 2 numbers and the entire distribution is pinned down. And here is why it is everywhere, the central limit theorem. Take almost any messy distribution, draw samples and average them. The averages, remarkably, form a bell curve, no matter how strange the original was. Whenever many small independent effects add up, the result is normal. That is nature's favorite shape, and now you know why. Machine learning leans on this constantly. We assume noise in data is normally distributed. We initialize a network's weights from a bell curve. We model uncertainty in predictions as normal. The bell curve is the default assumption whenever we do not know better, and often it is exactly right. So, distributions and the bell curve. A distribution gives the probability of every possible value. The normal distribution, set by its mean and standard deviation, appears whenever many small effects combine. It is the workhorse of uncertainty. But how do we update a distribution when evidence arrives? Next, Bayes' theorem, Chapter 20.